This is a problem where, just like the very first one that I showed you, we're going to use the formula for f to get a formula for f double prime, second derivative, use that to build a sign chart, and then answer questions about the shape of f. So this is very, very similar to what we did before with the first derivative, where our questions were about increasing and decreasing functions. So quickly I'll find the derivative of f. So f's derivative will be minus 4x cubed plus 12x squared minus 4. And take a minute to do that yourself if you're not following. But I'll just do it as quickly as I can to get to the new part of this problem. The second derivative then is minus 12x squared. Again, I'm just taking the derivative of the answer I just got, plus 24x. So in order to make a sign chart, just like before, I want to first find out where this thing is 0 or undefined. It's clearly defined everywhere. There's no division by 0 or square roots of negative numbers or anything that are possible here. So I would just set this equal to 0, look for a common factor. So 12x is a common factor in both terms. That leaves me with minus x from the first term and plus 2 from the second term. And I can see that when I have two things equal to 0, two things multiplied together would be 0. That means that either 12x is 0, which means x would be 0, or minus x plus 2 is 0, which would happen when x is 2. So x equals 0, x equals 2 are the two values that make my second derivative equal to 0. So now I'm ready to write my number, my sign chart. And again, I'll have my x's down here. I want to include 0 and 2. Up here I'm going to put the sign of f double prime. And I already know that f double prime is 0 when x is 0, and 0 when x is 2. So now I just sample a couple of other values, such as minus 1, 1, and 3, just so I have a sampling on all partitions that we get from these numbers. And then I just work out what these things are. So f double prime of negative 1 means put negative 1 in for x into my second derivative. Well, this is my second derivative formula right here. And again, you don't really have to evaluate it if you don't want to, but because all you really want to know is it positive or negative. But I'll go ahead and evaluate it just so we can see. If I put negative 1 for x, I get negative 12 there, and I get negative of negative 1, which is positive 1 plus 2 is 3. So I get negative 36 for f double prime of negative 1. So the main thing is that that's negative. So the f double prime is negative over here. F double prime of 1, similarly, will be 12 times 1, which is positive 12. So we're positive in here. And f double prime of 3 is 36. So 12 times 3 is 36. Times minus 3 plus 2 is minus 1. So negative 36 for f double prime of 3 as well. So that's what my sign chart looks like for f double prime. Up here, I would just write down what that means about f. This means that f is concave down, and then concave up, and then concave down again. So I can tell that f has this downward cup shape, then upward, then downward across these intervals. So now I look for the question. The question here was, for what interval was the graph concave up? Well, the only place the graph is concave up is here, and that would be between 0 and 2. So we would put an interval 0, 2. These values, the value at x equals 0 and x equals 2, we would say that we have inflection points there. So this term here, inflection point. An inflection point is simply a place where the concavity changes. So we saw up here that our graph did change from concave down to concave up, and so automatically we know that that's an inflection point. Up here we saw the graph change from concave up to concave down, and so immediately we know that that's an inflection point. So inflection point is just means a place on the graph where the concavity has changed, either down to up or up to down. finally, we have an example of an application, and the main thing here is just a piece of terminology. This is called the, where's the word? The point of diminishing returns. In an application problem, this is just specifically an inflection point where your graph changes from concave up to concave down. So when you have a graph, especially something like this, that is your production, rate of production, then this kind of growth you like, because not only is your production growing, but it's growing at an increasing rate. In other words, the slopes are increasing. And like we said, as you go left to right, if your slopes increase, you have a concave up shape. There will be a point where you can't be increasing at an increasing rate forever. So there'll be a point where even though you're still going up, you're starting to lose your rate at which you're going up. And so there's sort of two things that are happening here. This is an inflection point, of course, because this is a change of concavity from up to down. We call this the point of diminishing returns, and it has the property that this is where your slope is the greatest. So your slope was increasing, slope 0, slope 1, slope 2. You got the highest slope you're going to get, and then you start slowing down again. So this is the point where you have the maximum rate of change. And so in this case, we think of it as maximum rate of growth. So whatever you're doing beyond that, your growth is slowing down. It's not decreasing, but it is slowing down. So that's what we're looking for. So the rate of change of t-shirt production means T prime. T is the number of shirts produced by X workers. And so the units here, whenever we put something in for X, is going to be in t-shirts per worker. So that's the number of t-shirts that we can make per worker. And so the idea here is that we can keep adding workers, and for a while that's going to make our rate of growth for the t-shirt production increase. But after a while, you add so many people that you're actually just slowing down your rate of growth. So to find this, it's just a simple derivative. So up here, this is my t of x, so my derivative will be negative 3x cubed. I'm multiplying the 4 times the negative 0.75 plus 3 times 3 is 9, x squared. So that is the rate of change of t-shirt production. And so to get a feeling for the problem we're talking about over here with concavity, I'm going to have the second derivative. And I'll go ahead and make a sign chart here so that it's easier to look at. We know that on our sign chart, the first thing we need to do is figure out where whatever we're trying to find the sign chart for, we're trying to find out where that is equal to 0. And so to solve that, I need to factor. So I find a common factor of 9x. Both of these terms have 9x. The first term leaves behind a minus x. The second term leaves plus 2x. And so the only possibility here is that, well, 2, sorry. Better. Leaves behind a 2. So the only possibilities for x are that either x is 0, that's how the 9x would be 0, or x is 2. So I'd plot those on here. Since this is an application problem, it's worth noticing that 0 is not really a possibility. If you had no workers, you would have no production, so that's not really worth worrying about. And certainly there's no such thing as negative workers, so we don't have to sample over here to the left. So the only thing I need to sample is here at 1 and over here at 3. And again, I'm putting these into my T prime formula, so that's this guy. If I put 1 in for x, I'll get 9 times 1, which is positive. And if I put 3 in for x, I'll get 27 times negative 1, so that's negative. And so I do have this kind of shape where my graph is going to start off a concave up, and then when it gets to x equals 2, starts being concave down. So the answer here for rate of change of t-shirt increasing, well, that's the part I'm on this part of my graph. And so that in this problem is from 0 to 2. That's where I have an increasing rate of change of t-shirt growth. The point of diminishing returns then will be here at x equals 2. So 2 workers is good. More than 2 workers starts to have the diminishing returns. The maximum rate of change is whatever the rate of change is at this point. Remember, t prime is measuring the rate of change. So the answer to this last question about maximum rate of change is just t prime. That's my rate of change at 2. So that is the slope at the point x equals 2. That's the biggest that the slope ever gets. That's the highest that I will ever see my rate of change in this particular problem.